This video is with regards to number 10. So it says that a researcher was interested in the relationship between major and mathematics. Okay, so this seems to be a chi-square test for association. If there is an association or not between those two variables, major and mathematics. So he hypothesized that there was a relationship between the variables academic major and mathematics score. So that is the hypothesis, that there is an association between academic major and mathematics score. So for this objective, the data is presented in the following table to test the hypothesis by using the data. And the chi-square critical value is 2.706. The formula to calculate the chi-square test statistic, here it is. The sum of O minus E all square divided by E. And we need to calculate the expected value for chi-square test for association, here it is. Row total times column total over grand total. So here's the contingency table containing the data, the observed values, and the expected values were calculated. Here are the two variables, academic major and mathematics score. Okay. And as you can see, the academic major is divided into the natural sciences and social sciences, and the mathematics score is divided into two groups, those who scored less than 50% and those who scored more than or equal to 50%. So it appears that it was observed that 70 students from the natural sciences scored less than 50%. So it's like natural sciences and less than 50%, 70 of them. 80 students from the natural sciences and they scored more than or equal to 50%. Social sciences and less than 50%, 100 of them, and 50 students from the social sciences scored more than or equal to 50%. So that's what was observed. So the expected value is the row total times column total over grand total. So the row totals are 150 and 150. Column totals 170 and 130. That is 70 plus 100, 80 plus 50. 70 plus 80, 100 plus 50. So that's all the totals, the row totals and the column totals were calculated, and the grand totals, you can either add the column totals or add the row totals, and you get the grand total. Either way, here's the grand total. So that's why now for the expected value of 70, it will be 150 times 170 divided by 300. For observed values of 80, it will be 150 times 130 divided by 300. For the observed values of 100, the row total is 150, column total is 170, so it's 150 times 170 over 300. And for the expected value of 50, the row total is 150, the column total is 130, so 150 times 130 divided by 300 to give us a value of 65. So therefore now you need to please take out your pencil, your calculator, your paper, and to actually perform these calculations, participate in the video so that you can actually learn how to do this as a preparation for your valuation and for your long-term learning, how to perform a chi-square test for no association or chi-square test for independent. So let's move on to how to calculate the chi-square contributions now. So now we have calculated all the expected values. We can now proceed to calculate the chi-square contributions. O minus E all square divided by E. 70 minus 85 all square divided by 85. Right up to 50 minus 65 all square divided by 65. These chi-square contributions were added up to get a total of 12.22, which is the chi-square test statistic. So as you all know, the distribution curve for chi-square test is a curve that is skewed to the right. The critical region is on the right, and critical value is a positive number, which is on the critical point. Now we got a chi-square test statistic of 12.22, which is placed on the rejection region because 12 is greater than 2. So 12.22 lands in the critical or rejection region. Now here is the pair of hypotheses. The null will always say that there is no association. For the chi-square test for randomness, the null is saying that there is no factor affecting the distribution. For the chi-square test for variation, the null is saying that there is no variation. For the chi-square test for association, the null is saying that there is no association. So the null is always the conservative one. And here now, the alternative will be saying, well, there is an association, like two persons debating. Now, since the test statistic is in the rejection region, we have to reject what the null is saying. We have to reject that statement. And since we have rejected the null hypothesis, we are left with the alternative hypothesis, which will be our conclusion. So in conclusion, based on the data, there is an association between major and mathematics score. So please do this repeatedly to ensure that you can do it for your evaluation and for future purposes when you are doing your research, because this type of test normally quite frequently appears because it's very common to ask research questions such as, is there an association between these two variables? So you can perform a chi-square test for no association to determine whether or not those two variables, whatever they are associated with each other.